Find the concavity for f of x equals negative x cubed plus 3 over 2x squared plus 18x, and give the answer in interval notation. Alright, so we know that for concavity we want to find the second derivative. Okay, so well, we got to do the first derivative first, right? So let's take the first derivative. This is a polynomial. Okay, it's a third degree polynomial, so we know that it's we can differentiate it twice. Okay, so we'll just use the power rule here. We'll get negative 3x squared. In this case, bring down the 2 here, right? So that becomes plus 3x, and the derivative of 18x is just 18. Right, here's the first derivative. Now, of course, we use the first derivative to find intervals of increasing and decreasing, which will then, of course, allow us to find local max and local mins. Okay, so the second derivative is used to find the concavity. Okay, so let's find the second derivative here. We get negative 6x plus 3. Okay, so now we want to find our critical numbers, right? Let's set this guy equal to 0. And then we'll solve, right? So here we get negative 6x equals negative 3. So x just equals 3 over 6, which is a half. Okay, so that is our critical number. In this case, there's only 1 for the second derivative. Okay, so what we want to do now is make a number line, right? Or a sign chart, or whatever you want to call it. Right, here's 1/2. And what that does is it breaks this function into 2 intervals, right? We have one critical value. Okay, so negative infinity to 1/2, and then 1/2 to infinity. So that means, well, from negative infinity to 1/2, it's either going to be concave up or concave down. And same thing with this interval, right? Either concave up or concave down. It's not always the opposite, right? But this is a polynomial, so we know in this case, right, one of them is concave up, one of them is concave down. How are we going to determine that? Right? And that's done by picking a test point, right? We pick a test point in each interval, plug it into the second derivative, and just see what we get here. All right, so I'll plug in, I don't know, plug in 0 in this case, right? And I don't know, like 4, okay? As long as we're on each side of 1/2. So what is f prime of 0? Right, plug in the f prime, double prime I should say, right? F double prime of 0 gives us positive 3. Now the fact that it's 3 doesn't matter. What matters is that the answer is positive, okay? Similarly, f double prime of 4, right? We'll plug 4 into here. Negative 24 plus 3 is negative 21. Once again, the fact that it's negative 21, the 21 doesn't matter. What matters is it's negative. Okay? So wherever the second derivative is positive, that's where we're going to be concave up, right? So we're going to be concave up in that interval, right? Negative infinity to 1/2. And then we're going to be concave down in this interval here, right? 1/2 to infinity.